Bacteria are among the oldest living organisms on this planet, as well as the smallest organisms we still consider life. Because bacteria have been around for millions and millions of years, they have evolved in order to allow them to survive. Bacteria can be found everywhere: the human body, the food we eat, and even in the air around us. However, most bacteria are harmless to us. Our body hosts trillions of them, and they help us survive on a day-to-day basis. However, not all bacteria are harmless. Some can cause diseases and even kill people. Millions of people used to die because of bacterial infections until we developed a type of superweapon called the antibiotic. The antibiotic penicillin, discovered by Alexander Fleming in 1928, revolutionized medicine and saved millions of lives. Antibiotics kill the majority of susceptible bacteria fairly quickly, leaving only a small group of survivors that the human immune system kills off quite easily. But how do antibiotics do this? Bacteria are very complex creatures with thousands of complex processes that keep it alive and help it complete its functions. Antibiotics interrupt and mess with these complex functions to render the bacteria useless. An example of this is penicillin. Penicillin is an antibiotic that, once digested, will prevent the bacteria from synthesizing peptidoglycan, a molecule in between the cell wall and cell membrane of the bacteria that makes it strong enough to survive in the body. The drug will hence weaken the bacteria and kill off. This drug was used to treat many bacterial diseases and infections, such as pneumonia, tuberculosis, gonorrhea, or rheumatic fever. This is just one example, but other antibiotics work similarly. They also weaken the cells, but in different ways. Antibiotics kill bacteria, but what makes them very effective is that they don't attack the body cells that we need to function. However, antibiotics are slowly becoming less and less effective. This is because occasionally bacteria that is reproduced is more resistant to antibiotics than any others. This can happen when a bacteria, through evolution, mutates and starts investing more energy into evading or ridding itself of antibiotics. This means that the antibiotics that a person takes to kill the bacteria will not kill this resistant mutation. This resistant mutation can then pass along the trait of resistance through bacterial conjugation. Bacterial conjugation is the transfer of genetic material in which a DNA plasmid is transferred from one bacterium, the donor, into another bacterium via pilus. This resistant mutation, once dead, can also have its DNA harvested by surviving bacterium. This even happens through different species of bacterium and allows a bacteria to be immune to several different antibiotics. Natural selection is when organisms that are better adapted to their environment tend to survive and produce more offspring. Antibiotic resistance and superbugs are a consequence of evolution via natural selection. When a person ingests an antibiotic, it will kill the majority of the bacteria. However, there may be a few resistant bacteria. These will survive and then reproduce or pass on their genes to create more resistant bacteria which have a higher antibiotic tolerance. This cycle will continue and help the bacteria survive. This issue is so recent that examples of already existing antibiotic-resistant bacteria include carbapenem-resistant Acinetobacter, which causes pneumonia, as well as wound, bloodstream, and urinary tract infections. Another example of an antibiotic-resistant bacteria that exists today is the vancomycin-resistant Enterococcus, which causes infections in the bloodstream, urinary tract, brain, and heart valves. Another example is the extended spectrum beta-lactamases. It is a type of enzyme or chemical produced by some bacterium which disables antibiotics before they can work to treat infections. The most common types of bacteria that produce ESBL are E. coli and Klebsiella. In the modern world, antibiotics have been very normalized. This means that even if a person has a mild cold or any other mild bacterial sickness, they may turn to antibiotics instead of waiting it out and taking more appropriate measures. Rather than treating antibiotics as a last resort drug, as they should be treated, we are taking them as common medicine for mild ailments. By ingesting a lot of these antibiotics, the bacteria in your body will eventually evolve to become immune through natural selection and then reproduce until there is no antibiotic strong enough to combat the resistance of the bacteria. Another serious cause of the superbug issue is the meat industry. Businesses want the production of their products to be as cheap as possible so they can make the most profit from the sales. However, due to this, animals that are bred and raised to be killed in meat factories often live horrible lives. They are stuffed into tiny cages and crowded together. The environment is ideal for a disease outbreak. Manufacturers understand this and therefore add antibiotics to the animal's food in order to kill as much of the harmful bacteria as possible. Because of this, millions of animals all over the world are now hosting bacteria that is resistant to antibiotics. Their meat is then turned into food, and these antibiotics end up in human bodies. This is all done in order to ensure that their meat is as cheap as possible to ensure maximum profit. This goes to show how our food and healthcare systems are laying down the groundwork for a worldwide health crisis in the near future. According to a report done by the University of Sydney in April of 2020, superbugs could trigger the next global financial crisis. In the past year, hospitals in Australia have spent over $11 million treating only 2 of the World Health Organization's most threatening drug-resistant infections. The International Federation of Pharmaceutical Manufacturers and Associations predicts that by 2050, antimicrobial resistance could cost the global economy over $100 trillion. Already 700,000 people die a year of drug-resistant infections, and due to the lack of awareness on this issue, in the next 30 years, the rate of deaths per year could overtake cancer and account for 10 million deaths a year. This would push approximately 28 million people into poverty. This graph is a visual representation of my findings. COVID-19 has taught society the dangers of an unknown and difficult-to-cure sickness, and throughout the pandemic, millions lost their jobs and the global economy really struggled. This goes to show the effect superbugs could have on our economy. As well as this, when public health is at risk, it is virtually impossible to determine how the public will react. This would cause social and economic instability. This disruption would flow through every business, from large multinational businesses to smaller businesses, completely fracturing the infrastructure of our economic systems. One of the main causes for AMRs are food systems, specifically the meat industry. The meat industry makes a lot of profit due to the lack of investment into suitable animal pens. By attempting to change this, the meat industry would lose billions and meat prices would skyrocket. Eventually, the meat industry would collapse, pushing hundreds of thousands of people into poverty. To sum up the video, superbugs are a mutation of bacteria that allows the bacteria to resist the antibiotics that are meant to kill it. An outbreak of a drug-resistant bacteria could cause major issues to our society and economy. Therefore, we must address the problem and start trying to solve it as soon as possible to avoid a mass humanitarian and economic crisis.